Yes, we are live. Hello guys, welcome back to my new live stream. We are working on our project called Store Sales Prediction. Let me give you a quick recap. So we created a model called model.pkl and our scalar file scalar.pkl, and now we are trying to create a Flask web app for this model, for deploying this model, and we getting some error in this web app. So today we will resolve this uh, error. Let me try to run this. Give me some, let me give some random values. So let's see. This is giving us error. Naming prediction. Let's see. Here you can see. So I work on this. What I'm getting there. Let me copy that thing. Let me open that, and then I will explain you what we have done. Let me copy this complete code and paste it here and save this. Also we have to change these templates also. So let's see what I have done. So in our index, this is our home page. So I guess I explained you in yesterday's session. We created a item identifier, item weights, item fat content with two options, that is low fat regular and item visibility. Now if you see, we are typing this as string, and then when we load this like let's say item visibility, now we are getting taking it as string, but when we load this from HTML, here you can see here, then we will convert this into float type. Okay, and and then now here it comes my web app. So it is home. For home we will render this index.html, and when we submit our fill our form, then we will click on submit button, then this query happen, and we get, if request method is equal to post, we will get our MRP value as float type from item MRP, and get our outlet identifiers. If our outlet identifier is equal to out027, then we will give as one value in out027 and 0 value to 019. Similarly, we will do same things for these all variables, and then we will create. We will also we imported numpy arrays to create a numpy array for all these variables. Here we first created numpy array of all the elements, and then used dot reshape to reshape our array, and then use transform because we have to transform our values for scalar variable, and then we using our model, we use model.predict dot for scale values, and after that we round our output up to 2 decimal points, and then we return render template prediction.html with the result value as prediction. Prediction is our output. Okay, let's see what's inside the prediction.html. So here you can see we write your total item outlet sales is. You can see here we give the variable result. So for this result we initiated this value, or you can say define this value prediction. Result is equal to prediction. Now let me run my web app. Let's see how it works. Oh, it's running. Cool. So let me just see my local host. Here it is. Let me try to run. Now if you can see, now I am giving float values and I am not getting any error. Yes, you can see your total outlet sales is 3600.95. You can see here it is only on up to 2 decimal points. We also added a home button so that we can click on that and go back to our index.html page. And now we can deploy this into our Amazon EC2 instance. Let's see. For a moment, I have to hide my screen because I have to log in on my AWS console. Let me first close my web app, and so our web app is completed. We can commit this for for a second. When we are deploying it on AWS EC2 instance, we have to change here. We have to use host is equal to 0.0.0.0, and our port will be 8080. Let me save this, and then also for our web app we have to create an environment, like which libraries it has to or you can say install, or it has to install for running this web app. So now we can do one thing. We can create an Anaconda environment. Let me, and there we will try to run this web app and install our requirements, and then we will save that requirements into requirements.txt file. For just a second. For creating conda, for creating a new web environment, I have to run this command c conda create -n. This is our environment name. Let me call it as sales store, and our Python version is, if you can see, I used here 3.1.1 3.11.5. so I am in this I will also install 3.11.5. Here I will hit enter, and it will say so then environment. I type y and hit enter. Oh, sorry. Let me see my live route. Yes. So we can activate this environment and change our directory to our store sales prediction directory. First we can change our directory. I guess for that we have to use here, and after that we have projects directory, and then it is in stores. Let me do step by step. Change directory, stores. So we are in this directory. Now let me activate my environment. Activate sales store. So now we are in a sales store environment, and now we will use pip for installing our libraries. Pip install Flask. Already set aside. Okay. Now I will try pip install NumPy, because I need for running my web app I need NumPy request and pickle. Pickle will be in our scikit-learn library. So let's see NumPy, and my NumPy version is earlier I have seen that my currently NumPy version 1.25.2. Let me install this version. Oh, let me see what's my current version. How can we see? How to see your NumPy version? Using pip show NumPy. Okay. So I have to run this command on my this terminal. Pip show NumPy. Okay. It is 1.2.2. It is 1.25.2. Then what I have put? I wrote the same thing. Oh, I have to give 2 equal to. Sorry. Okay. And let's see what's my scikit-learn library version. For that again I have to use s scikit-learn. Scikit-learn. So our scikit-learn version is 1.3.0. Cool. Let me go back to this my sales store environment and now install scikit-learn. Scikit-learn. Our version is 1.3.0. Let's install it. Okay. Now we can do one thing. We can try our web app. It will run or not. Python dot Python space our web app name, that is app.py. Try to. So we have to also install request library. Let me install pip install requests. Now let me run python app.py. Hello. Okay. Let's see. So our web app is running. Cool. Now we can close this and we will type pip freeze -r, or let me see the what's the command for this. Pip freeze understand requirements dot txt and hit enter. Here you can see a requirements.txt file is created. Now we can deactivate our environment. I guess deactivate conda is the, or conda deactivate. It's conda deactivate. Okay, we are now come back to our base environment. Also, I want to delete this sales store environment. For that, I have to use conda remove minus name. Okay, conda remove minus name. Our name is sales store, and then minus all. We have to type y and hit enter. So we have successfully removed our sales store environment. Now we can close this up. And here you can see in requirements.txt file, this is the all libraries we want for running this app.py. And let me do one thing for a moment. Let me go to my AWS console. Just for a moment, I will close my screen. Here you can see I log in my AWS console, and now we will click on EC2. And now create a new instance. For new instance, we have to click on launch instance. We will give a name called store sales. Let me. We will take a free machine. For that, let me see which is in free tier. I think yes, this is. So here you can see for EC2 we get 750 hours per month free, which is T4G2 dot small Linux. Let's see. Let me browse. We will take Linux environment, or you can say Ubuntu. Ubuntu free tier eligible. Yes, we will select yes, and then yes, this is also free tier. We will use t2.micro and key pair. Always try to create a new key and save sales store, and always save this PEM file. This is our public key, and just no other settings, just launch our instance. So our instance is successfully launched. Let me see. So this is pending. Let me restart this, refresh it. It's pending. So our server is running, or you can say our instance is running. We can do now one thing. We have to install putty software. For that, so this using this we will give commands to, you can say we will connect to our EC2 instance which we made, that is sales stores. Okay, also using this, if you can see, we have sales store.pem. We have to first convert this into ppk file, that is uh, private key. We will do this by putty key generator. Putty key generator. Just a second, let me see. Here it's putty. It's putty gen. Okay, now we have to load our. We have to select all files, then select our public key. Successfully imported. Okay, let me see. My screen is visible or not? Yes, it is visible. Cool. Now we have to save our private key. Save, or you want to save this key without? Yes. We will save this as store sales, I guess. Words. Let's save as store sales. Save. So let me see. Here you can see this is our ppk file. So now we can close this and we will go back to our putty. Let me again search for putty. Double T. Yes. For host name we will use here, you can see here's the public IP. We can copy this and we can paste it here, and load. So we have sales store. After that we have to give we have to go back to credentials, private key for authentication, browse, and we will select our key. Okay, and we are ready to open. Just accept. I guess we have, I think we have done some mistake. Let me again try this. Okay. Our host name is again same. Let me cross check it. It is 43.20. Okay. SSH. Okay. Sessions, stores, save, login. No, we do not have to change anything. I think all things are. Yes, we have to give the login username. We can say our username is, here you can see it is Ubuntu. We will click as, we'll type Ubuntu E2. Okay, and then I think let me click, go back to auth section. Here again we will select our store sales, and now let's try again. Yes, here you can see we are now in our EC2 instance with the username Ubuntu. Okay, let me do this chain directory to, or we can say, just a second, we have to install one another software. Let me see. Yes, we have to install WinSCP. Again, hostname will be our whatsoever. Just copy this hostname and paste it here. I think why this is not new site. Can we now paste? Yes, we can paste it here. Our username is open. Let me see the hostname. Ubuntu. And we do not have password, but we have a private key. For this we have to click on advanced, and here you can see we have authentication private key. We have to redirect to our private key and select that. This is in downloads. Okay, then click on OK and then login. So now this is my PC's directory, or you can say personal computer directory, and this is the my EC2 instance directory, or you can say root. So I can copy my you can say web app from this to my EC2 instance. Okay. So my web app is in stores sales prediction. Okay. So for running my web app, I need, we can create a new directory and then save this. Let me create a app and we will save this. For that I need templates. Just drag and drop. I need app.py. I need model.pkl. I need scalers.pkl, and I also need requirements.txt. Cool. So now if we see, let me do ls. Here you can see we can see our app directory here. Let me change directory to app directory, and then ls. You can see we have all these files. Now just one thing, we can run this, but first we have to change our security group. If you can see here, or you can, oh, we have to networking. We have to create a new security group and add that security rules in it. Let me go back to security groups. Create new security group. My security group will be sales store sg. For description we will type full access. So because we are giving inbound rule of full access, you can see, I think all, so we are giving access for all HTMLs. Okay. Okay. I think we have to select custom for port range 8080, or let me see. Are you already created a security group of full access? Here, let me see. Port range is on. Sales store SG full access, add inbound rule. Okay, add. Okay, so we can create this security group. Now we go back to instance. We will select this and hit on Magin networking, attach. We can see. How can we here you can see change security group. Can we add security group from this? Yes, we can add security group from there. Let me save this. So let me see. So here you can see we get 0 0. Okay, again let me go back to my putty and let me install Python. First check, is there Python already? What's the command for Python installation? Using sudo apt install. Okay, we have to use this command. Then Python replace install Python 3.1.5 using sudo apt. So first we have to update our sudo, and then we have to use this. Okay. First we have to update our sudo, or you can say we have to update our apt, then we will use this command. Let me see if we can type on it will install or not. Could not find package. And let me remove .file. Let me hit Y. Now it's running. Let's see. Now let me how to let me check it. Is pip available? Pip not found. Sudo apt install. Oh my god, we have to install this for pip python 3 pip 8y. It's installing. Nice. Which service should be restart? Okay, like okay, this let's see what. Now let me install pip install -r requirements. Let me check. How to install packages in Python using text file. We have to use pip install -r. Okay. Pip install -r requirements. Hit it. So it depends on your instance network speed, how fast it is. Speed and like cool. So let's now What could happen? White killed. Let's see. Now let's try to run Python app.py. Python not found. Do you mean Python 3? So we have to use Python 3. Okay. 3 app. We have to install Flask. But why this torch is equal to? Let me again run. Again 6. Let's see. Oh, it's taking so much time. It's running. That is running. If it do not succeed, then we can do one thing. We will try to again this is killed. We can try no and try to overwrite this requirement.txt file, and here we will remove it is which package? I think torch. Yes, it is torch. Let's try to remove this package, and then so we have to write our control O and then just hit enter and then control X. Again we will try P++. Again, then why again this is running torch? I forgot to edit text file in Linux. Also we can use V. Just let's see. It's again killed. We have to. It is torch. Torch is not here, then why? get requirements. Let's see, torch is not here. Then why this is installing torch again and again? Okay, try to just kill this command and again try to run this app. And if we get error, then we install our libraries manually. Okay, we have to install Flask. Okay, pip install Flask. Again, let's try to. We also need NumPy. So pip install NumPy with version 1.25.2. So NumPy is also installed. I think then we will also need scikit-learn. Let's see. Try to. Also we need scikit-learn. Okay. Then scikit-learn. For this our version is 1.3.0. Let's see. It is successfully installed. Now try to run this app. So our web app is running, and for using our web app we have to use this public address with port 8080. Let's see it will connect or not. Why it is taking so much time? Let's see. Let me see the security rules instance. Here let me see security. So we added security group. Okay, good source. Let me see for this. Here it is port range all, but in store sales it is just 0 and protocol. So we have to edit our security group, or we can say we have to create a new security group. Let's see. Again create a new security group. SSSG full access. Create a new bound rule for all traffic with anywhere. Again with all traffic for IPv6. Create security group, and now in instance let me Let me remove this security group and add SSG. Here it is SSG. Add security group. Save. Now again. Here you can see our web app is successfully running. Let me predict some value. Here you can see my web app is successfully running in my EC2 instance. Here you can see. Let me close my web app now and let me delete this instance and terminate this instance. So before that I have to I have to close this and then terminate successful. Shutting down. Till then we can delete our security group, which is SSG, and save store SSG. Actions, we can delete security groups, confirm by typing delete. Delete. So let me refresh it. You can see our security groups are deleted. Now let me see instance. Is it terminated? So it is terminated. After some time this will you can say this will disappear. Let me now log out. So our this project is completed. Now we will move to one more thing. Let me commit these changes. Git add on git commit -m. What's my message? It is day 3, project completed. So let me also push this to my GitHub. Push -u origin name. Let me see in my GitHub. Here you can see we got our all commits. Yes. Now we head towards our next project. Let me also delete this. All commits. So let me see what's our next project. It is campus recruitment prediction. So it is a Kaggle competition. So for downloading this dataset we have to, I guess, join the competition first. Let's see. Yes, we have to join the competition first. I understood and I accept. The page shows the data files here. Okay. Data fields. So there is 3 data fields or multiple. Let's check. So there is multiple data fields. We have 3 files. One is training file and another is testing file and another sample of submission. Okay, cool. Let me download all files. We do not need sample submission file. We just need train and test file. Let's see. Train, download test.csv, download. What's our project name is campus recruitment prediction. Let me create a new directory of name campus recruitment prediction. I hope my spelling is correct. Let's see. Recruitment. Yes, my spelling is correct. Okay. Let me cut this file and paste it here. Okay. And open my VS Code. Now open new folder, which is our campus recruitment prediction. Again, let's initialize our git. For this we have to use git init. So our git repository is initialized. Git add git commit -n. So documentation is very important. If you are working on anything, we have to document each and every step. So it is the initial commit. Now you can close this and create a new notebook .ipynb. Let me take my global environment and first we import necessary importing necessary libraries. So this is our project number 2 in our live session. Okay. Import numpy as np, import pandas as pd, import matplotlib as plt. Just a second. .pyplot as plt. Import cbone as sns. Let me import CSV files. Let me initialize pd dot read csv, and this is our training set. So for that we have to use train dot csv df dot head. Let's see what's okay. So we have so much column. Let's see what's the shape of df. So it has 15 columns. Okay, I think we have to predict salary. So we have serial number. Let me df dot columns. So we have serial number, we have gender, we have SSCP, SSCB, HSCP, HSCB. It is degree, work experience, E-test P. What is this E-test? Then MBA, or it is engineering test, I guess. Then specialization, status, salary. Let's explore this dataset. df.info. So again, MBA has float value, EST test P has E-test P has a float value. Again, degree P has float value, but degree T has object value, object data type. Sorry. So let's see what's okay. Here you can see it is other. So B is for board and P is for percentage, I guess. SSC percentage, SSC board. HSC percentage, HSC board. HSC stream. Okay. It is high school. It is secondary school. Okay. Now in degree, how much percentage it get? It got. What's the degree? You can say stream name, or you can say a if it is experienced or not. Okay. E-test P. We can first drop our serial number because we do not need serial number. Let me drop this. We can write what dropping SL code, I guess. SL column df drop which column SL underscore no. Our axis is 1 because it is a column, not a row, and in place is equal to true because we want this we want to save this in df data frame. Okay, now let's see, is there any null value or not? Checking for null counts. For that we have point df dot is null dot sum. So we have null values for salary. It is around 67 and our data frame shape is 215. So we cannot drop these values because so we can do one thing. We can fill any values with mean value or median value. Let's see. df of first check if there is a duplicate value or not. Drop duplicates in place is equal to true. and then let's see if our shape is reduced or not. So there is no duplicate values. Cool. Now we can fill any values with salaries, mean value or median value. Salary dot ds dot mean and df of salary dot median. There is a slight gap in between these two values. What we can do, we can visualize this plt dot hist for x-axis as df of salary and bins is equal to 20, let's say. So if we can see, our most value lies in between here. Let me increase my bin size. I have to plt dot. So we can fill our non-values with our median value because it is right skewed. Let's see. Right skew distribution. Yeah, as you can see in right skew distribution, this is our mean value and this is our median value. So, and this is our mode value. So we will replace our main values with median value. Okay. df of salary filling nan values with median value in salary column. Dot fill na, and what is the value we have to fill? That is df of salary dot median. And now let us check, is there any nan value or not? Df dot is null dot sum. So there is no null values. Now we can see unique values in object format. Yes, in object data types. For that, we can use obj is equal to empty list and for call in df of columns, because we need this in one hot encoding. When we will do one hot encoding, we also need this object data type, I mean columns with object data type. So we will combine, or you can say contain, this all column name with object data type in object obj list, you can say. We will append this if df of call dot d type is equal to object. Then what we have to do, we have to first append call dot, sorry, we have to append this in object. And what we have to append, we have to append call, and then we have to print. What we have to print, we have to print column name, comma, then we have to print unique values inside the column. And then we will print count of unique values. We can do one thing. We can copy this thing and see length of, then paste here. Let's try to run this. So here you can see SSCB has two unique values, HSCB has two unique values, HSCS has three unique values, degree T has three unique values, and work experience has two values, and specialization has two values. Okay, status placed or not placed. So we can do one thing for instead of, I think I am trying to say in work experience we can use no for we will replace no with 0 and yes with 1, and in status column we will use placed for replace placed with 1 and not placed with 0. But let first uh, we visualize our data, or let's visualize our data. And one more thing, if you are running out of ideas, how can I visualize my data? You can see, you can do one thing, that is, let me just do one thing. df.head. You can take help of ChatGPT also. Let me show you how you can take help. You can give me visualization idea for this data set. This will give you multiple ideas for that. So it is giving me to we can draw pair plot, we can do histogram, we can plot box plot, bar plot for work experience, pie chart, self distribution. Let's see. First we try to plot a pair plot. Create a pair plot to visualize the relationship between numerical features, that is SSC, HSC, degree for different genders. Each point can be color coded based on the gender. Let's see. Let me first plot an histogram for gender. Is there any column named gender? Yes, it has gender. So gender has, I guess, two unique values. Let me cross check here. df dot df of gender dot unique. Yes, this has two unique values. I guess one for male and another is for female. Now we will try to plot an histogram. For that, SMS plot, we can see here gender distribution. Distribution. SNS dot hist float data is our df, and our column is our, what's our column is gender. Plt dot show also give me title. Plt dot title with gender distribution. Distribution. Also we can do one thing. What we can do. We can erase this and see. Plt dot xtick and use labels 0, 1. It will give us error dot. So we have to give 0, 1. Now it's looking nice. Cool. Now our aim is to create a pair plot. Pair plot for numerical variables for different genders. SNS dot pair plot. Data is our data df, and who is our gender. Let's see what we get. Plt dot show. I think we will get an error or something else. Next time I will import warnings because I am getting these warnings. This is not a very important warning because it's just giving me future warning that is gettable data type is deprecated and will be removed in future versions. So here you can see I got a nice visualization. I will go for SSCP, HSCP for degree P and for e-test P for MBA and for salary. We can see there is a marginal salary gap in male or female salaries. Also you can see. Oh, you can here see one gender has more, you can say, more percentage. That's why we are getting high salary for that gender group. For gender 0, gender 0 has a higher SSC percentage as compared to gender 1, and similarly in HSC we are getting high, you can say, marks for gender 0. Okay, so what we can do next, we can do histogram plot histograms to show the distribution of numerical features. This is for both genders. This can help in understanding the distribution of academic performance for different groups. I think this is the histogram, so we do not need to draw another histogram. Let's see what's next. It is box plot. Create a box plot to visualize the distribution of numerical features for different specialization. This can help in understanding variations in academic performance based on specialization. We can do this. Note it is box plot, I guess. Yes, it is box plot. Data will be df and x will be our which column. First we do it for SSCB, I guess. No, it is SSCP. And our who will be different specialization. Okay, who will be different specialization. Okay, peer depot show. So I'm not expecting this. Let me do one thing. We can copy paste and take help of GPT itself. Write a Python code to create box plots. Okay, so we have to split the. Now I get it. Okay. So we have to filter the specializations, and then we have to. Let me copy this code here, and then let me delete this specialization. We have to filter data for. Let me see specialization, unique values for specialization. So we have two unique values, marketing and HR and marketing and finance. And we can create a different data set. So we can copy this thing and similarly. We not plotting the in the same manner. We will plot different you can say for different features. So we do not need these features column. We have to just copy this thing. And instead of features, we have to just type our column name. Initially, we will print it for SSCP. We will type SSCP, and then our data will be this. So we concatenated this data. Cool. We can copy this thing also. And instead of feature, we can type SSCB. It should be in string. SSC P, again here SSC P. Yes, here you can see we get our box plot nicely. So one more thing. Yes, I am trying to ignore these warnings. Not that import warnings and warnings dot filter warnings and type ignore. Yes, now we do not get any warning. Here you can see. Here you can see. And put this also. Now we will do the same thing for different columns. For I think HSC. Let me do it for H. Yes, you can see the difference in this. Our next picture is degree P. Here you can see. If you can see from all these graphs, uh, students with higher percentage values, they are more selecting marketing and finance instead of HR. If you can see here, here also this is following the same trend, and here also we can do this same thing for MBA and ETSP. Okay, for MBA and ETSP. For a test, a test. And one more thing, why I am initializing this again and again. I do not need this to define again and again. Yes, one time I have to make this cool. Let me run this for eTestP. Here you can see again, this is following the same trend. Let me again copy it for MBA. No, here it is not. Yes, it is following the same trend because you can see this is our median value and this is our median value. There is a gap in between median values. Median values. Okay, cool. Now what we can do in our next visualization, we can do bar plot, create a bar plot to show the count of the placement for each gender. Okay, and so we can do a histogram. Yes, we can do PRT, sorry, SNS dot is plot. Data will be df, and x will be our placement. What it is? What's the column name? It is where the placement. It is status. Status, and then who by gender. And period dot show. Let's see what we get. So here you can see, okay, so we have more values of gender 0, that's why we are getting the thing. But you can see gender 0, it is I guess male or female, I don't know, but let's see. In competition it is given 0 is for sex of employee. No, this is not given. So the gender 0 is getting more placement as compared to gender 1. Here you can see from this graph, because there is not placed, difference between placed and not placed is quite very high in gender 0, if you can see. Okay, and bar plot for work experience. Create a bar plot to show the for based on work experience. Okay, this can help me. So we have to do the same thing, just we have to, we can give a title also, title. Also we can give a x title, x label, sorry. X label of placement status. And our title will be distribution of, or you can say placement status distribution with gender. Here it looks nice. We can copy the same thing, and instead of gender we can do this for, okay, same for our work experience. I think work experience, work X is the column name for this. Let's see. Yes, you can see the people with the people with work experience getting more jobs, or getting more placement as compared to uh, which people do not have experience. Here you can see. Nice. Now we hit what's our next. Really, we can create a pie chart of distribution to visualize the proportion of different specialization. Yes, we can do this. For that we have to do SNS plot pi or PLT dot pi. Let me see. Pi Yes, and our x will be df of specialization dot value counts, and for labels I have to use same thing but use this index. I have to use this index. Okay, and what's next parameter? And let me try to plot this title with what will be the plot title pie chart for pie chart of specialization. PLT dot show. Let's see what we get. But we do not get values. For that we have to choose, I guess. Let me see. For showing PLT dot py. Let me see documentation. Label size code, and for this we have to use okay. We can here put this. Now we get a percentage. Okay, cool. So there is a more persons or you can say students are in finance department. Cool. Now what's our next? We can create a sales distribution plot histogram or blocks plot to visualize the distribution of sales for placed candidates and set the range. Okay, let use GPT for this. Python code to correlation heat map. This thing this will be do after some time because only we can do we will do it now. This code. Just sorry. Let me just comment it down. Erase all these libraries. So it is placed. Okay. Place data, salary. We can remove this also. So this is creating box plot. Let's see what we get. We'll be getting a nice distribution. That for a moment we comment out this and uncomment this. I think histogram is better. Let me uncomment this. Distribution of placed candidates. Here you can see We can do one more thing. We can do same thing for not placed candidates. Oh, I guess we created a blunder. We have to fill any values with zeros. I guess. Let me. Yes, I created a blunder. In it is in status, I guess. Status dot value counts. We have, I guess, 67 non values initially. Let's see. So it is 67. If not placed is equal to 67, then yes. So we have to, okay. So we created a blunder. We have to correct this thing. Just let me cut this cell and place above the fill enable. Here, let me paste this cell. And now we will fill any value with 0 because these employees are not placed yet, or you can say these students are not placed yet. That's why we are getting this n value. Okay, so we have to again run this entire code. What we can do, we can do this. So this will run complete. It is creating a pair put. We can remove this because not placed is, if it is not placed, then cell distribution will be 0. We can cross check this. Let me just see. Just state unique values in status. It is not placed. Right. Yes, I guess it is saved. Yes, it is saved. And placed, or you can say not placed. Not placed. We will get, I guess, empty distribution. Let's see. Yes, you can see it is a 0. We can delete that distribution. Now we can, oh, so now we have to create an heat map also. We have to create an heat map with numeric values. So for that, I will create columns without object data type. Okay, let me initialize an empty list for col in df dot columns if my df col dot d type is not equal to object, then append this into columns list, cols list, col. Okay, let's see what we get. Okay, and hit enter. Now we can define df with calls. Here you can see we get all numerical values. Okay, core. We can save this in. We can save this correlation into core value, or you can say core variable. Now our aim is to create an heat map, and we give value as core. Let's see, priority dot show. Before that we have to add priority dot title, and our title will be heat map for, or you can say correlation in numeric variables. Numerical. And one more thing, I have to just see that I have to give a notation is equal to true. Here I'm getting the values for correlation. Okay. Now we can do one hot encoding. Yes. Let me do one more thing. Let's see what's that df dot head. I think if there is one value of correlation between status